Hello, I'm Roman, and welcome back to the series of the videos Neural Networks from Scratch in Go, where we're using this book called Neural Networks from Scratch in Python, but we writing everything with a Golang. And in the previous video, I started chapter 18 already, called Model Object, and the idea that we will implement the model class that we can configure in such a way where we can submit a bunch of the layers. We can submit the loss that we're going to use. We can submit the optimizer that we're going to use, and we can call the train model. And for me, I'm looking into things that I need to implement here, but the problem, well, not the problem, is Go is more strict to things that you have. I mean, the way that you write classes, it should be strongly typed. And what to do? What I mean by this, I need to do certain changes into what? Into my code base. I have a to-do list that I need to do. I had couple more things that I fixed in the previous one. Actually, I think I need to I would commit this. Yeah, I created the main thing. I would say I created the interfaces for the model. So we have the layer interface, we have the loss interface, and we have the optimizer interface. And all of the things that I already implemented right now follows these interfaces. And I started to build the Go, and started to build the model. Well, it's not the class in this case, it's the struct, but the idea is the same. So we have things. Yes, this is what I had. So I had to create the three interfaces. The tricky part will be to refactor the loss functions so they will work on the generic maths, well, on generic dense class right now. For example, the categorical cross-entropy loss and the binary cross-entropy loss works with array of the unsigned integers, while the regression model works with because the regression model tries to predict a numeric value, it works with the slice of the floating points or floating point values. But I need to make it, but it's not working with an interface that I create. So right now, if I take a look, there is a interface for the loss function that takes, well, in the backward, it takes target as a float 64, I mean the slice, and this is the main thing. I mean, I can go with the slice, but for example, for the regression model, it won't work because right now, every value in the target array represents only one output value for the model. And if, for example, I would like to have a model that predicts several numeric values, then I need to have arrays of array. Yes. Uh, so I think it should be better to replace it with the dense class, like I have with the d values, with the predictions, and then each particular loss will have to validate the date. So for example, in some case, I would assume that it has only one, how it's called. It's not actually a two-dimensional array, it's one-dimensional array, and I will work with like this. But we'll go. Okay, so introduce model structs and interfaces. Okay, so I will fix these things once I think I will get to the train. I think, yeah, once I get to the train class, I will need to actually implement the train function. But let's go next. To actually train, we need to perform a forward pass, performing this forward path in the object is slightly more complicated because we want to do this in a loop over the layers, and we need to know the previous layer's outputs to pass the data properly. One issue with querying the previous layer is that the first layer doesn't have a previous layer. The first layer that we're defining is the first hidden layer. Yes, so okay. One option we will have is there is to create an input layer. This is considered a layer in the neural networks, but doesn't have weights and biases associated with it. The input layer only contains the training data and we will only use it as a previous layer to the first layer during the duration of the layers in the loop. We'll create a new class and call it similarly to as layer dance. We'll call it layer input, and all it takes is the inputs. Well, it's the output, but the idea is actually right now I'm thinking that both right now I'm looking at this, and the interesting part, if I compare the activation and what's activation and the layer, I need to expand. I need to expand. What is this? Think. I need to expand the interface to have the D inputs and the output as the requirement for the interface, because the model will work through the interface. And yes, I think those two things are common. We have the inputs, but it's not exposed anywhere, so I'm not sure that I need to I'm not sure that I need to what's called expose it outside, but we'll see. I cannot declare a function, really? Oh, I mean, I cannot declare the variables inside the layer interface? Seriously? Yes, this is the function. Where is the next one? Type T struct. Okay. Mm, So I cannot guide to so I cannot declare an output. So the interface set of the method signature that the type can implement. Therefore, the interface defines the behavior of the object. The definition is simple. Okay, so I cannot put a requirement for to have a specific field. But I mean, I can do things like get output, right? But then get the inputs, right? But then what it means, I can do basically that will be like this. Yes, I have the linear activation and it will be get outputs, right? And it returns reference to the dense and we expose it as out, right? And then we do the same for get the inputs, the inputs gets output, right? The inputs. Then we have the same for the relu, right? What it will be activation. What do you mean? Really? I have it as outputs. Okay. Let's make it consistent. Right. Relu. We have the sigmoid, the same sigmoid. And we have the same for the softmax. Softmax. Right. But it should scream on the layer. Okay. Site layer, and that should be, and we should have the same for dropout, right? Dropout and dropout. Right? Right. Interesting that it didn't scream. Okay. Probably because it's not used. Okay. Okay. Where did I layer inputs? I need to have the layer input. That's input layer go. And well, I think I will copy the dropout layer. Input. Okay, so what we have? We have the input layer. We don't, well, that's the thing. I do need to declare the inputs, I think for now, but I'm not sure. I don't need this. The forward method will be just, basically I need to store as output what is inside input. In the backwards methods, I actually need to panic. Should not be used. Vision site. %s dropout layer. It will be input layer. Input layer. I think the same with the inputs. It should not be used. Inputs layer. Inputs. The idea of the input layer is just to take the data from it. So then we have the model, right? The forward method sets training samples as a self-output. This property is common with the other layers. There is no need for the backward method here since we'll never use it. Yes, but uh, if I want to have this loop and the chain and model will work, so for example, I mean the layers. I mean that's the question how to do this, because I could have it as a separate field. In that case, I don't need for the input layer to conform to the protocol, or I can pass it into this array of the layers too, just into the initial, as the initial, what is called, layer. And then we'll do proper backward forward pass, and the backward pass will stop, and the backward path will stop, right? So I'm still not sure how to do this, but let's see. The forward method sets training sample as a self-output. This property is common with other layers. There is no need for backward methods here since we'll never use it. It might seem silly right now to even have this class, but it should hopefully become clear how we're going to use it shortly. The next thing we're going to do is to set the previous and the next layer properties for each of the models layer. We'll create a method called finalize in the model. All layers except the first and the last one. The last layer, the next object is the loss. Oh, I've been thinking maybe I can generalize them, but the problem that for the layer interface, for the layer calculation, for the activation function and for the layer itself, the forward and the backward method doesn't return anything, while the loss interface is actually, all of the loss functions, first they have a different signature, second one, forward, specifically the calculate method returns something, right? So I'm not sure. I'm not sure about this one. I'm thinking even this one, I'm not sure why I need to set up this. Okay, so for the layers and self layers forward, layer dot prev dot output. Call forward method on the input layer. This will set the output property that the first layer in the pref. In this case, we take x. Okay, let me check. And the train will be output self forward x. Okay. Full class at this point, so add okay, loss optimize okay, finalize train. Call forward method of every object in the chain pass output of the previous object as a parameter. But how it will work with the activation function? At this point, we have covered the forward pass of our model in the model, but we still need to calculate loss and accuracy along with the backpropagation. Before doing this, we need to know which layers are trainable, which means layers with weights and biases that we can tweak. To do this, we need to check if the layer has either a weight or the biases attribute. We can check this with the following. Okay, set trainable layer, where I is the index of the layer in the list of the layers, we'll put this code to the finalize method, the full code. That method so far we create in the input layer, initialize a list containing trainable layers. Okay. If a layer contains an attribute called weights, it's a trainable layer. Add it to the list of the trainable layers. We don't need to check for biases. Checking for the weights is enough. Next, we will modify the common loss class to contain the following. Common loss class. Set remember trainable layers. Calculate the data and regularization losses given model output and the ground truth values. Okay. Calculate sample losses, data loss. Okay. Return the data and regularization loss. Okay. The remember trainable layers method is in the common loss class, tells the loss object which layers in the model objects are trainable. The calculate method was modified to also return self.regularization loss during a single call. The regularization loss method currently requires a layer object, but with self.trainable layers property set here, method we can now iterate over the trainable layers to compute regularization loss for the entire model rather than one layer at a time. Okay. Okay. Focal probably will check the I will check the whole code until the end to see how it looks like, because I will do it in a different way, I think, but I need to understand what is the target thing. Calculating accuracy, we need predictions. So far, predicting has required different code depending on the type of the model. For softmax classifier, we do np.argmax, but for regression, the prediction is direct output because of the linear activation being used in output layer. Ideally, we could have a prediction method that would choose the appropriate method for our model. To do this, we'll add the predictions method to each activation function class. Okay. All the computation made inside prediction functions are the same and those performed with appropriate models in the previous chapter. While we have no plans for using the relu activation function for an output layer activation function, we'll include it here for completeness. Okay. We still need to set reference to the activation function for the final layer in the model object. We can later call the predictions method, which will return predictions calculated from the output. We'll set this in the model class finalize methods. Last layer, the next object in the loss. Also, let's save aside the reference to the last object, loss output in the model's output. Output layer activation. I mean, then I don't get why we need self.layers. We could just have the input layer, then I could have the trainable layers, and then have the loss and have a reference to this one. Just like the different prediction methods, we also calculate accuracy in different ways. We're going to implement this in a way similar to the specific loss class object implementation. We'll create specific accuracy classes and their objects which will associate with models. First, we'll write a common accuracy class containing for now just a single method, calculate, returning an accuracy calculated from comparison results. We have already added a call to self.compare method that does not exist yet, but we'll create it soon in other classes that will inherit from the accuracy class. For now, it's enough to know that it will return a list of true and false values, indicating if the predictions matches the ground truth value. Okay. Next, we calculate the mean value, which true as 1 and false as 0, and return its as an accuracy. The code. Okay, so we'll have the compare, then we have calculate the okay. Next, we can work with the common accuracy class, inheriting from it, then building further for specific type of the models. In general, each of these classes will contain two methods: init, not to be confused with the Python's class init method. For initialization from inside the model object and compare for performing comparison calculation. For regression, the init method will calculate an accuracy precision, the same as we have written previously for the regression model and have been running before the training loop. The compare method will contain the actual comparison code we have implemented in the training loop itself, which uses self-dot precision. Note that initialization won't recalculate precision unless forced to do so by setting init parameter to true. This allows for multiple use cases, including setting the self-precision independently, calling init whatever needed. Okay. Calculates precision value. And okay. We can set the accuracy object from this. Okay. Then we can finally add the loss and accuracy calculation to our model right after the completed forwards pass code. Note that we also initialize the accuracy with self.accuracy.init, which takes the ground truth labels at the beginning of the chain method, which can be called multiple times, as noted earlier. In the case of regression accuracy, this will invoke a precision calculation a single time during the first call. The code of the train method with implemented loss and accuracy calculation. Perform the forward path. Data loss regularization loss we take from the loss.calculate. Okay, that should be the same. So I will need to change this one as I talked before. Then I get predictions, calculate the accuracy, the output layer activation predictions. Okay, accuracy, self.accuracy.calculate from the predictions and the ground truth. Finally, we will add a call to the previously created method remember trainable layers with the loss class object, which we will do in the finalize methods. Full model class so far. Is it all for the loss? Now that we have done a full forward pass and have calculated loss and accuracy, we can begin with the backward path. Okay. Maybe make the full train methods. Our new model is behaving well, and now we're able to make new models very easily with our model class. We have to continue to modify these classes to handle for entirely new models. For example, we haven't yet handled for the binary logic regression. For this, we need to add two things. First, we need to calculate the categorical accuracy. Okay. Okay, now that's where I will quickly scan through this. When we are training, we'll engage the dropouts. If not training, return values. Yeah, I don't like these things. Full model class. Okay. It seems like everything working, isn't it? Now that we have got this model class, we're able to define new models without writing a large amount of the code repeatedly. Rewriting code is annoying and leaves more room to small, hard to notice mistakes. So this is the changed code. That's kind of well, that's pretty a lot. Okay. All right. I mean, now I have an understanding what, what has to be done in the end, right? So let's continue. I stopped here. I still, okay, where I think that was, yeah, I think this is layer pref output. Call forward method of every object in the chain, pass output of the previous object. Yeah, but I don't understand why I need this one. So why I need the to set self dot, set the loss. Maybe for, maybe actually for the backward, because I don't think I need this. I mean, I can go through the, let me check the backwards. Backwards. Okay, loss backwards. And output, and then reversed. So layer next the inputs. Okay, so the difference is when I will need to write the forward and the backward methods, I will need to write a special case for the first iteration. In the forward, I will need to take the data not from the like previous layer, but actually I need to take it from the input layer. For the backward methods, I need to do the same for the first iteration. I mean, here that will reference the inputs from the loss, right? But I can just check if it's the first iteration from the reversed list of the layers. I just take the data for the backward method from the loss, the inputs, else just take it from the previous layer. And I can take the previous layer just with the index, and that's it. Because I don't want to increase number of things that are already in the layer. If you take a look at the layer, there's already a bunch of the things. So there is a weight cache, momentum, and lots of the other things. So I don't want to do this, really. But I need to create the, by the way, when the finalize is called, table contents. Okay, finalize the model, so we will do some things there. Okay. Just kind of finalizing the setup. But input layer. Okay. I will do it this input layer, and that will be actually an input layer, right? Layer. The input layer will always be the same. Okay, then I will have model, how it's called, finalize nothing inside. So what I need to create actually layer input layer, right? And that's it. We're not passing. I'm not going to do this because I will kind of move this logic into the forward and the backward methods. I think I need to do other things here, but not for now. The next thing is model, actually the forward methods, right? So one, we have model, right? Forward, and it should take the X inputs, which will be a dense, right? And what we're doing? We're doing the input layer, we call in the forward, and we pass in the input, right? Right. Return layer dot output. Okay, so we actually returning this one. Then what I'm going to do? I need to go through for I layer in the range of m dot layers, right? And this is what I've been talking. If I equals to 0, then I'm calling layer forward, and I'm taking data from first layer. But in any other case, I'm using the forward methods, and I need to get previous layers output. What it means? It means that I have m layers -1 and get output. By the way, do I have the get output? Right? Okay. And then I'm returning what I'm returning. I have the layers, then I have the length of the layers -1, so basically, and get output. That should be the last one. All right. Layer is now the last object in the list, returning its output. Okay. For example, I have some model. Main, no, not this one. Main. Okay, I have some value. Maybe I should create a normal one. Where it was an example. Okay, let's replicate this. We have X and Y as the sign data. X, Y, data set, sign data, 1000 cases. And we have the model. Okay, then what we should do? We have the layer 164. So it's 164. Then I add model, add activation, which one? Relu, right? Then we have the second layer, which will be 64 by 64. 64 by 64, and we have again rel. Then I'm creating the last one, 64 by 1. And here I think linear activation. Yes. Activation, linear activation. Okay. Loss mean absolute mean squared error loss. And we have the new, and we have the Adam as optimizer. We set in the okay, learning rate 0.005, same for the current. And what is decay? Decay 1e minus 3. Okay, this is the model. Okay. So I have the forward that returns from forward pass and returns the output. In this case, we take the X input data, then simply pass this through the input layer in the model class object, which creates an output attribute for this one. I mean, okay. Yeah, okay. Let's use the input layer as just holder of the training data. But basically, I could just hold the reference because I'm not using this trick with the output. I still kind of check in if it's the first or the second one, but okay. Output attribute gets created for each layer. We'll call the forward method, which is then used in an input to forward call for the next layer. Yes. So how it will work? On the zeros on the first layer, it will call forward with data from the input layer, and we'll go for the next one, and it will take, for example, if it's I, so it's an activation, it will take the output from the first layer that was the normal layer and call the forward for it. Sounds reasonable. Once we iterate over all the layers, we return the final layer's output. That's a forward pass, and now let's go ahead and add this forward pass method called to the train methods. Okay, where I have the train 26 up. So we have the output. Output equals to m forward x. Output declared, that's not used. Okay, fmt print line mat output. So we have, for example, main. Basically, it should be model finalize, model train. We have X, we have Y, we have 10, and print every 100 times. Yeah, you're right. You're right. You're right. I know this. Okay, maybe I should start changing it. Okay, so the train XY, here's already my dance. So then it should cannot use Y. Why? Wait. Okay, let's sign. So here it should return two dances, right? So how it will look like, it's okay, but instead I will return it as math new dance one row samples data x math new dance, again, 1 samples, y. Okay. My build. Okay. Okay, it works. Okay. Full model class. So we have the layers, we have the append, we have setting the loss in the optimizer, we have the input layer. I don't do this stuff. I have this one that is, oh, okay, I have +1 here. It means that I don't need to do it here. I have the forward path that calls forward on the input, then go through the rest of, well, actually layers. Okay, so running this, well, yeah, actually, if I run this, it should give me some results. Boom. Then math model 20. 80s. 51. How I created it before, maybe as the columns, right? That was the regression model. Yeah, I have it. Um, okay. Sign data. I will need to find how I want to return the y value as the row or as the column. That's still to do. Define dimension for y. Yeah, that's white prints. That's often. Train. Hmm, train. Okay, so it's empty print line. And 70. I mean, I will do something interesting. I will do something nicer here, but okay, it's training. Well, I mean, it does something, but there is no changes because there is no actual training. Okay. Then at this point, we covered the forward pass of our model. In the model class, we still need to calculate loss and accuracy along with doing backpropagation. Before doing this, we need to know which layers are trainable. In my case, all the layers will be trainable. I mean, in the layers array. I'm not going to add the input layer and the loss object into the layers. It just will make my life harder, and I'm not sure why I need to do this. But I'm actually, I think this is the good point to stop and continue tomorrow. So initialize a list that contain the trainable layers. Yeah, I think because of the, you can do all the kinds of the strange things in the Python. They need a way to check if it's trainable layer by checking the weights. In my case, I just use the layer interface that does this thing for me. So okay, I'm not doing this. This is I have kind of by default, and the idea that we will pass it into the loss. And the next thing, actually, I will need to check if I can implement common things like calculate and remember trainable layers for the loss interface, because right now the loss interface is just a requirement for all of the loss functions. And I think I will need to add this as a requirement. But then I'm thinking, I'm not sure. I think I can implement a function on the interface. So instead of having the calculate function implemented everywhere, I will need to move it. Well, I hope I can move it into the interface implementation. And then there is a very big question with this line and this line. And right now you can see that the target is float 64 slice, and I'm going to change it into the dense, and that will open the open the whole of the compilation errors that I will need to fix and face. And yeah, that's the good starting point for the next video. The next video I'm going to tomorrow on Monday. Oh no, next video I'm going to record today, but I will record tomorrow, but it will be published on the Monday. So yeah, good start for the Monday with lots of the errors and another set of the refactoring. Thank you for watching, and I see you tomorrow. Bye bye.